doing implementation of handwritten digit. Okay. Let me share my screen. So please open our notebook. Let's continue implementation of our handwritten digits. Open a notebook and just run entire notebook. Yeah, done loading. So we were doing a project related to handwritten digits classification. So wherein first we loaded data from our Kaggle Hub, imported Kaggle Hub, and then we took a path of it, and then we just downloaded, right? And then we listed all the directories, and we displayed 5 images, and then we counted number of images in each folder, and we created data frame, which includes image path as well as the labels. And then we shuffled the data because so we wanted to mix up all data together so that it doesn't really result in bias. And then finding height and width of an image. And then I guess I was discussing about how to split data for training and validation. Yes. Okay. How do you split data for training and validation? So already discussed. So right after we train a model, immediately we have to, what we have to do? We have to validate a model because so many images will be there. So it has to finish the entire process, right? So that's the reason we'll be splitting our data for training, testing, as well as for a validation. So once you split, we have to implement the data cleaning process. Like we have normalization and different other things. And then we'll do the model implementation. Okay. So yeah. So since I said we have to split data for training testing, 70% will be used for training and remaining 15% will be used for validation and remaining 15 for testing. Okay. Yeah. So first let's define our train size. So I said 70%, so I'm just defining integer of 0.7% of your overall data. So data is data, no? Not a DFU. And then just use validation size. I'm just finding what is 70% of your data, what is 15% of your data. 15% means like 0.15 into length of data. And then for testing, test size equals. That's the first thing. You find what is 70% of something, what is 15%, what is 15% of testing data. Done? If you want to see what is the train size, test size, you can actually say. Overall, we have somewhere around like 22,000 something overall data. So 70% of it is like 50,000. 15% of it is like 3,233, and 15% of overall data is 3,233. So this is the first. Okay, first we are just finding the size. Now you have to split it. How do you split? So I'll just call train data equals. So I'll just call data.log colon train size, in the sense like we want everything from beginning till 15,088, right? So it will be starting from 0. So it's a train size. Okay. And then for validation data, it should be data.log. So now you want from train data to, that is train size to train size plus validation size. And test data equals data.log. See, you'll get the same thing. Since we are using an index, don't use a log, better use an iLog. You'll get a proper sizing now. It's still 3, 4, this one. How come test data is more? Getting the same thing, but that shows one extra. No, it will be one extra only, all right. Cleared, understood. Understood what's happening. So it is taking everything from colon till 15088. Then you are starting from 15088 till 15088 plus 3233. That is the second one. This is like data.ilog, everything from beginning till this number. Next one, data.log and then data.ilog colon. So here from 15088, that is from your train data. So we want it till this value plus your validation size 3233. Okay. And then for this test data.ilog, it's a train size. So train size is 15088 plus validation size colon. Everything from this till here. Done. Till last. Hope it's clear. If you want the same thing, then I guess you can get it from 1 to. It's still this sequential less. Understood this? Is it clear? This is how we split data for training and testing. Then, so once you are done with splitting your data for training and testing, the next important thing is you have to import certain libraries. Already I had said that. So we'll be using TensorFlow. So import TensorFlow as TF from TensorFlow. Import Keras. And then from TensorFlow.keras dot preprocessing dot image will be importing just import image data generator. So which is basically used for pre-processing your data. So import image data generator. So these are the three important libraries which you have to import first. The important libraries. Done importing. Then. So I said that in a image classification, we don't train all the images at a time. So basically we create a batches. Okay, and each batch will have the number of images as like 32. 32 images will be there. And we know what is the image height. We found it in the last class. Height is 90. So, but I give a standard height and weight so that it adjusts all the images to that particular range. So we just take 128 image height and image width. Then we have to perform a data cleaning. So I'll just define a function called as a data generator. Okay, data generator equals, so it's an image data generator wherein its rescale equals 1.0 by 255. So rescale basically used to normalize, converge all pixel ranges to a 0 to 1. Usually pixel range will be 0 to 255, we know that. Pixel range 0 to 255 will be converted into 0 to 1, bringing all pixel to a same scale. That's done by a rescale. Okay. And then we use a rotation angle. So rotation angle is used, rotation range. So I'll just say like 14. So it will randomly rotate all the images up to plus or minus 40 degrees. Rotates a image up to plus or minus 40 degrees. Okay. And then And then we use width shift range, which is equal to 0.2. That means width shift basically helps you in moving your image towards right and left. Okay, moves an image. Then we have a height shift range. Zero point 0.2. Again, here moves image up and down by 20%. Then we have a shear range. So when I say shear range, it will slant the image. So we say it 2.2%. That means slants the image. Or like it's just pushing it in a sideways. It's all that we are doing in this way so that a model can understand images in a different angles. And then, so if you want to zoom it, you can specify a zoom range which is equal to 0.2. Horizontal flip will be true. Flipping image like left and right. And then we have one more fill mode. So fill mode equals nearest. So when I say nearest, if there are any gaps in our images, that will be filled using the nearest pixels. The gaps in image, when we move that, it creates basically a gaps. So gaps in image is filled with nearest pixels. Well done. This is how you define your data generator. Now this data generator has to be applied on train data, test data, as well as on a validation data. That's it. That's a basic cleaning we perform. So we'll apply it on a train data. So I'll call it like a train generator equals call your data dot generator dot flow from data frame. This data generator has to be applied to the entire training data. So we'll be passing a data frame, which is train data, comma, X value will be image path. And your void column is label. Target size equals image height and image width, comma, You have to define a batch size. Batch size already defined, it's a 32. You can take that variable itself. Comma, class mode. So it's a classification thing, no? So class mode is a categorical. We have a labels. Categorical, comma. So we have to shuffle all the images. So shuffle equals true, comma. State is just like a random state, which maintains the randomness. Yeah. This is how you define a train generator. It's not data dot, it should be data underscore generator. Whatever we have defined here, we are taking that. Okay, we're calling that image generator variable, and we are passing all the train data by passing x-axis is going to be like image path, y is a label, height and width of an image, batch size. What did we define? Not an image path. Let me check my data. It's img path. So whatever naming you gave, the same naming has to be used. Now it's applying all those pre-processing steps on a training data. Almost we have 15,000 something images. Now it's applying on all the images. See, so we have 10 labels. So all 15,000 images are validated and they belong to our 10 classes. So we have images related to all different 10 classes. Okay, for all those images, we have applied the cleaning process. Hope it's clear. Same way, we'll do it for our test data as well as for our validation data. Okay. So what happens with test data? Same. So it's just underscore generator equals data generator dot flow from data frame. So data frame is going to be test data, comma, X column is image path, Y column is label, and then target size is image height and image width, and then batch size equals and then class mode equals shuffle equals 2, seed equals 42. Here, comma is missing. So now this entire process will be applied on 2000 plus images were there, no? So on all those test data, it will be applied. Same way, do it for validation. The same code for validation. Change it to validation generator, and here just change it to validation data. Done. Okay, done. This is how the cleaning will be applied on train data, test data, as well as on a validation. Hope it's clear. Understood? Now, if you want to see the shape and how many batches it has created, so what you can do is, I hope it's done till here. So just use for image batch command labels batch, then page generator. Let's say you want to print train shape. So within a curly braces, you can just write image batch dot shape. And also you can print the batches. So batches equals length of your train generator. If string expecting colon. Okay, this is closing. This is closing. Yeah. But I've closed now. Mm. Use a common bracket here. Yep. So it will be printing for all the things. So that's the reason, just break it. So it will not keep printing the same thing again and again. You can see 32, 128, 128, 3, and batches is 472. So what do you mean by this? Same you can copy paste for test generator. Here you can call test. Same thing you can do for validation generator. Here you can call validation generator. Yeah. So tell me, what does 32 stands for, 128 stands for, what is 3? And also, what is that 472 and 102? So in this case, 32 represents a batch, images in a batch. 128 is the size of an image, height and a width. 3 represents RGB channel. And batches equals 472 in the sense for a training data, it has created 472 batches. Each batch will have a 32 images. For training as well as for a testing, for test data as well as for a validation. So it has taken only 1 or 2 batches because the data was less. Understood? This is clear. Any questions? Understood. Okay. So this is all about, splitting your data for training testing as well as cleaning your data. This is how you do it. The next important thing, you have to build a model. So when I say build a model, you have to import certain libraries. So since we'll be using our TensorFlow and Keras, we'll import certain libraries and then I'll show how to implement it. First, from TensorFlow.keras, just import layers, models. And then from TensorFlow.keras dot optimizers, import Adam. Adam is the optimizer we are using. And the loss function. So TensorFlow dot keras dot losses. We have to import categorical cross entropy. These are the 3 important libraries you have to import it. Since it's an artificial neural network concept, it has a different layers. So since we'll be adding our different layers, we have a concept called as a layers. Since it's ANN based algorithm, so it uses a back propagation wherein you have to find a loss. You should use an optimizers in order to update the weights and bias. So for that, we'll be using an optimizer called as an Adam. And we need to evaluate the loss, right? So we have a different loss function. Binary cross entropy, categorical cross entropy, MSE, MAE. Since it's a classification problem, that too we have like multiple labels. We have almost like 10 labels. So we just use categorical, cross, entropy. Hope it's clear. If then just take a break and then I'll show you how to add a different layers and how to evaluate the model. So people are back, we'll implement the CNN model. Okay. So first thing, you have to define like how many classes you have in this. So according to this data, we have 10 labels, right? Yeah. So let's just define number of classes equals 10. Okay. And then let's define a CNN model. CNN model equals call your models dot sequential, and then start defining your layers. So how do you define? So I'll just call layers dot. The first layer should be you have to pass input shape of your data. So I'll be calling layers dot input, and you have to call your shape equals 128, and you can use a 3. Height width as well as 3 is RGB image. And then we'll add a convolution layer. So layers dot. So just use convolution 2D. So I'll be passing out 32 filters, and each filter size we define it using the kernel size, which is 3,3, and activation function used in convolution is rel. Okay. Then you have to add a pooling layer. So it should be layers dot max pooling, and you have to pass pooling grid size 2 cross 2. Okay. So like this, you have to repeat your convolution and a pooling layer multiple times. So I'll be repeating just 3 times, and kernel filters I'll be changing to 64. Okay, done. Then you have to flatten it. So I'll just call layers dot flatten. Once you flatten it, you have to define your hidden layer. So I'll be calling layers dot dense. I'll be passing 64 neurons. And again, in our hidden layer, activation function is going to be relu. Comma. I'll call layers dot dense. Final output layer, wherein I'll be defining number of classes, which is already defined like a 10. And then activation function and final output layer should be softmax because it's multi-classification problem. That's it. This is how you define different layers in a convolution. This is how you define different layers in convolution. Clear? Understood? Next thing, we have to compile a model before we train. I just defined the layers now. Okay. The next important thing, you have to compile it. Just call your CNN model dot compile. Compile in the sense kind of adding few things, like we'll be adding a loss, which is going to be the categorical cross entropy, and then I'm defining optimizer, which is Adam. We have imported all this, and then we have a matrix, which is accuracy I'm using since it's a classification. Once you compile, next important thing, you have to fit it. So how do you fit? So I'll call CNN equals CNN model First, we define all the layers, then we define loss function, optimizers, and a metrics to evaluate. Then you have to train your model, CNN model dot fit. Pass your train data. Okay. And you have to tell like how many times you have to run this entire process since images are like high. So as of now, I'm just going to try with 5 epochs. It takes time, even for 5. I want you people to try for at least 20, 30, or 50 epochs after a class. Just run and leave it and do some other stuff. It will finish the process. In a deep learning, implementation is easy, but it takes time to run the entire process. Okay. It might take now more than half an hour, even for a 5 values. So, and then I'm just giving 5 epochs. It's like number of iteration, number of times my training should happen. And then after every training, it has to be evaluated, right? So just call validation data equals. It's a validation generator, comma. It has to write some text regarding like every training process. So verbose equals 1 in the sense it prints things related to your model. See, just run. Basically, it will take time. What happens now? I'm asking you to train it for 5 times, right? In a first iteration, it is going to train your model for 472 batches, wherein each batch will have a 32 images. Getting? You can imagine, right? One batch has a 32 images like that. 472 batches will be sent to your model. So that should be sent 5 times. That's a 5 epochs. Okay, you can see every time it is calculating loss and accuracy so that you get to know for every batch like how loss reduces, how accuracy increases. If you try for at least 30, 40, 50 epochs, sometimes 100 epochs, you can expect the better results. Okay, so it takes time. So I'm showing just with the 5 epochs. Even this, it might take, I don't know whether it finishes in next half an hour. It takes time. Only if you use a different epochs, you can see like how well it is going to work. Understood? It will take time. Hope it's working. It takes time. So tomorrow before you come to a class, just 1 hour before, just run your notebook for different epochs, at least for 10 epochs. So you can see like how you can make a prediction or how you can evaluate the model. Can you see finally done with one epoch? You can see for the next epoch, the loss is reducing, accuracy is increasing. The same way, as we increase the iterations, the model performance will increase.
Hello, ma'am.
Yeah, I'm there. The code has to run, so we are waiting.
No. Screen is not visible actually. Yeah, now it's visible. Okay.
It's visible.
Student asking.
Yeah. Guys, you can see the accuracy is increasing, loss is reducing. So for 5 epoch, you don't see much improvement. You have to do it for at least 20, 30, or 50 time is also good. So before you come to tomorrow's class, make sure you run before a class. Almost done, but still it takes time. Two more are there. Okay, just write a code, run for some 30, 20, 20, 30 or 50 epochs. You do some of the work. It will finish the task. So once this is done, it has to evaluate the overall model performance. I don't think for 5 epoch it will do something better. It's good if you go with at least 10, 20. So you could see some improvement. Okay, so if you want to evaluate this model overall, you can evaluate it using, I'll just show you one code. If you do it for 20 epoch, it will show something like this. Can you see? It will take more than an hour. It starts with an accuracy 0.15, and for 20 epoch, it has reached up to 86. Still, if we try up to 30, 40, or 50, you can achieve till 90. More we train, the better performance will be there. Okay. And then you have to evaluate a model which gives you overall performance. Then you have to plot a graph. Shall I put this code in our notebook? You just run the notebook for at least 20 or 50 epochs. And then you can also plot a graph just to understand how your loss varies with accuracy. See here, as you increase your training, accuracy should increase, loss should decrease. No other option for a deep learning and all, you have to wait. You should have a patience. You don't get things immediately. But writing code is easy. Run and just do some of the stuff. It will finish the task. Okay, and you can actually make a prediction. See, I have entered a 3 image, it is predicting it like a 3. Okay. For evaluating model, I'm just calling CNN model dot evaluate, pass your training data, overall training accuracy it gives you, and also test it for test data also. And then finally plot this graph. Okay. You can copy from my notebook, I'll upload. Or else just open my notebook, create a copy and run it. Run for at least 50 epochs and see how well the model performance will be. Okay. So prediction I'll show it tomorrow. Before a class, I'll try to run this notebook. Just try 1 hour before if you are using a 20 epochs. If you are using 50 epoch, 1.5 or 2 hours before. Okay. If you are interested in making prediction, I'll just give a code, but you can try it. So simple, you'll be taking an image from Google, upload it, write a copy, a file name here, and then just load it. It will make a prediction. Okay. Whatsoever images you take or whatsoever data sets you take, the process is same. Only difference is the time it takes to run. You have a patience to wait, then it's easy to do. Clear, understood. Which epoch running for you? Fourth, fifth? Anybody completed all 5? But still see like 4, it's just a 0.56. You can't expect a better results. Here, understood. So before tomorrow's class, make sure you run this notebook. do it for at least a 20 epoch. 20 is okay. 86% is like not bad. It makes some mistakes happen, but still manageable. But try for 30 epochs. Even I'll try after a class for 30. Just run and keep it, that's it. It will automatically do that stuff. Clear? Okay then, thank you. We'll do one more project similarly, and then we'll start with NLP, natural language processing. Even that takes time because all these things will be using our different layers. So wherein we'll have our epochs. We train it with different iteration, with different batch sizes. So it takes time to run the code. Okay. Thank you then. Let me upload this into your drive. But please run it just after the class. Just make it to 20, 30 epoch and see. Rest all I'll discuss in our next class. 26. Thank you. Thanks for joining.